convert this into an internal structure, okay, in this form. Now, first of all, we make an assumption. When we call the build general tree function, the input is not empty. Okay, so if the input is empty, then you don't need to call this function. Okay? Now, if the tree you are going to build is not empty, then the tree will be defined within a bracket, right? Okay, now what do you need to do? Okay, what information you need to know? The input will be stored, is assumed to be stored in a character array. Okay. Now, let's simplify the problem. That every not label is a single letter. Okay, and you only have the open and close bracket and the letters in your input. Okay. Now, to build the tree, now the overall tree is specified or enclosed by a pair of brackets. Okay. So it means that what you need to know in the tree construction, you need to know where is that starting open bracket in the input, right? Now, when you create the internal representations of a tree, when will you know that you have complete the task? You know that you have completed the task when you see the corresponding closing bracket. Then you know that you are done. Okay. And after you have created the tree, there should not be anything remaining. Okay. Now, but during the process, you will create the subtrees using recursion. Okay. Now, first you start from the root, and then when you create the subtree, this part is the subtree. Okay. Now, how many characters will your functions consume when you create a subtree? It is something that you don't know in advance. Okay. So that's why when you are processing the input and creating the internal representation, okay, the index value will be keep moving. Okay? So in this case, we define the parameter I that represents the starting position of the open bracket in the input while we are creating the subtrees to be passed by reference, such that when we change the value of I, okay, it will be visible. Okay, so we make changes in one recursion. Okay, then it can be visible when we go back to the previous level of recursion. So we know how many characters in the input that have been consumed. When one of the subtrees has been constructed, we continue to build the remaining parts of the tree. Okay, so this part is important. You need to first of all decide how to pass the parameters, what to do with the parameters. If it is changed, do you need to know that the new value of that parameters? Okay, so you make a recursions to construct the subtree. When it returns, you know that now the next character that you consider for the next subtree will be starting at a new position. Okay. Now, when we create the subtree and the precondition is that the tree is not empty. then the character at the index I should be the open bracket. Okay, so the input to the function. Okay. So this is the index I. So index I must be referring to the open bracket that defines, okay, the beginning of the subtree. Okay. Then what will be the root label? The root label will be the next character. Okay, because the tree is not empty. Okay, because in the representation we won't have an open empty bracket to define an empty subtree. If the subtree doesn't exist, we don't need that empty bracket. Okay? So the next character after the open bracket is assumed to be present, and it is the root label. Okay? And we make use of these properties. First, we create the root node. Okay. We set up the label of the root node, and the two pointers of the root node is initially set to the node value. Okay? And then, now after we have consumed the open bracket, the root label, now I is increment by 2. Okay, because it is now referring, okay, either the end of the tree, the closed bracket, or it is the beginning of a subtree. Okay? So after incrementing I by 2, we test to see if it is the closed bracket. If it is closed bracket, then we are done. Okay, the creation of that subtree is completed. We start from the open bracket, now we see the closing bracket, and we are done. Okay. Now if we are done, then we return the root node. Okay. We don't need to further process. Okay. If it's not the closing bracket, then it means that the root has one or more subtrees. Okay, because now following the label, if it is an open bracket, then it means that it's the beginning of a subtree. Okay. Now, when we call the function recursively to build the subtree, now it is expected that when this function returns, what will be the value of the index I? Index I must be at once to pointing at the closing bracket of the subtree. Okay, now this is the requirement. Okay? Now, when we create the first subtree, it will be connected to the root through the left pointer. Okay? Now, after the creation of the first subtree, now what will be happening internally in the program? It has created the root A and now created a subtree where the root is B and there's something, okay, below B. But when it returns, now the index I is pointing at the closing bracket for the subtree B. Okay? Then we will set the pointer P to point to, okay, the subtree. Now P is changed to point to the left pointer of the root. Okay, now P is pointing to the child. As long as, okay, the next character after the construction of the subtree, the next character is not the closing bracket, meaning that now for the current tree, root at A, we have not reached the end. Okay, now if the next character is not the closing bracket. Okay, and it means that we will create the next subtree of A. Okay, now the next subtree of A will be connected to the right pointer of P. Now, the next subtree will be connected to the right pointer of B, and this is the root is C. Okay? Now, what is the starting positions of the next subtree? It will be I plus 1. Okay, because when the recursion returns, I will be pointing at the closed bracket, then the starting position of the next subtree will be I plus 1. So I is increment, then call the function recursively to build the next subtree. Okay. Now when this recursion returns, I will be advanced to point to the closing bracket of the subtree. Okay? And okay, we come back to the while loop. Increment I by 1. Okay, if we haven't seen the closing bracket now, but in this case the next character is the closing bracket, then we are done. Okay. Then we increment I by 1 again, then I is now pointing at the closing bracket for the tree whose root is A. And it returns the root pointer. Get the idea? Now the important point in the design of this kind of algorithm, okay, you need to observe, okay, what is the loop invariant. Okay, I have mentioned this term many times. Okay, but whether or not you really understand how to apply this concept, I don't know. Okay, but the way that, okay, I try to explain the algorithm is based on this idea of the loop invariant. Now, in this case, the loop invariant will ensure that we start from the open bracket of a tree. Okay, when that recursion complete the construction of that tree, the index I will be changed to point to the closing bracket of that tree. Okay, so it will tell you which part of the input has been consumed in the construction process. So now if you start from the most basic structure that you have one node in the tree. Okay? Now if this is the starting index, if you go through the algorithms, you see that it creates, okay, the root. Okay. The two pointers are set to node if the character, okay, now I is incremented by 2. Now I is now referencing, okay, the closing bracket. Now if the character at this position is the closing bracket, then you are done. Okay, you don't need to do other work. Then you return the root pointer. Okay. Now the next example. Now you start from the index I. Okay. In this tree, A has one child, that is B. Okay? So the program in the top level create the root. Okay. After creating the root, I is now updated to point to the open bracket corresponding to the subtree. So you need to create the subtree. Now we use recursion to create the subtree. Okay. Now in that subtree, it has one node, so the behavior will be the same as the previous example. Now you call the build general tree function recursively to create the subtree and connect it to the left pointers of A. Now after the recursive function return, I is now pointing at the closing bracket of the subtree. Okay. So it means that when you return here, okay, sorry, right now you are here. Okay, when it returns, okay, now I will be advanced to point to the closing bracket of the subtree. Then what you need to do is to test if the next character is the closing bracket. If it is the closing bracket, then you are done. Okay? If it is the closing bracket, you don't need to go through the while loop, you just increment I. Now I is changed to point to the closing bracket of the O4 tree and you return. Okay? One more case. This is the starting value of I. First, the program creates the root. Okay. And I is now updated to point to the open bracket of the first subtree. Okay. Then the algorithms create the first subtree, and now I is pointing at the closing bracket of the subtree B. Okay, so when you arrive at this while statement, the character at I plus 1 is not the closing bracket. And it means that the parent node has another subtree. Okay, so you enter into the while loop, increment I. Okay, now I is referencing the starting open bracket of the next subtree. Call the function recursively to build that subtree and connect it to your previous subtree through the right pointer. Connect it to the right pointer. Now after this recursion returns, what is I? I should be pointing at the closing bracket of C. Okay? Then after you have created the next subtree, you move the pointer P to the next child. Okay. And come back to do a test. Okay. Is the next character is the closing bracket? Yes. Now you are done with the construction of the tree whose root is 8. Okay, and then you update I to point to the closing bracket is this part. And after that you return. Now the invariant properties that we are maintaining in the recursive function is that we start from the open bracket of a subtree. When it returns, the index I will always be updated to point to the corresponding closing bracket of that subtree. Okay, so this is the loop invariant that we maintain in the design of this algorithm. Okay. Now, if you try to, or you need to, in the future, implement computation of this nature, okay, whenever you use recursion or looping, think about the invariant properties. So in every one full round of iterations, what kind of properties that you need to maintain in your control variables. If you can't figure it out, then there's no hope that you can write your program. So whether or not you learn the skills is your effort. Okay. I can't change the way that your brain operates. Okay, it is not programmable. Or uploading or downloading a patch, like your mobile phone. Once in a while, there's an update to the OS. There's no such update to human brain. So if one day, if this is possible, then depends who has the resources. Okay. The guy with the resource will be the leader and the king of this world. Okay. So he can always update his own mind. Okay. So any questions? Okay, so if not, then I think we will stop here today.